Topic 2, differentiation. At the end of this video, you should be able to A. Relate the concept of derivative of a function to the gradient of a tangent. B. Find the derivative of a function using first principle, limited to linear function, quadratic functions, and reciprocal function. Look at the diagram below. Given point P is on a curve, the straight line touching the curve at point P is called the tangent to the curve at point P. Tangent means a straight line that touches the curve at a point, mean only one point. The gradient of a curve is a measure of its slope, and the value of the gradient changes at different points on the curve. Therefore, we define the gradient at a point P as the gradient of the tangent at that point. Derivative from the first principle. The purpose of getting the tangent line or gradient at a point A on the graph is called differentiation from the first principle, or differentiation using definition. Thus, f prime x equals to dy dx equals to limit f x plus h minus fx over h, where h approaches to 0. Note that though we choose to use a fractional of representation, dy dx is a limit and is not a fraction. Dy dx doesn't mean dy over dx. Dy dx means y differentiated with respect to x. The d dx is the operator operating on the same function of x. Look at example 1. Find the derivative of the following functions with respect to x by using the first principle. Fx equals to 3x. Based on the first principle, f prime x equals to limit fx plus h minus fx over h as h approaches to 0. So therefore, f prime x equals to limit 3x plus h here. So means we substitute x with x plus h minus 3x over h as h approaches to 0. If we substitute the value of h equals to 0, so we get 0 over 0. So this is indeterminate form, IDF, meaning that we need to do something. Therefore, we expand and simplify that function so that we get limit 3 as h approaches to 0. So the answer is 3. Next is fx equals to 5x plus 4. So we substitute into the first principle, therefore f prime x equals to limit 5x plus h plus 4 minus 5x plus 4 over h as h approaches to 0. If we substitute value of h into that function, so we get 0 over 0. Same case, from example A. So we need to do something. So we expand the function and then try to simplify it. So from that we can cancel out 5x and 4. So we get limit 5h over h as h approaches to 0. So from that we simplify again until we get limit 5 as h approaches to 0. So the answer is 5. Next, fx equals to x squared. So we substitute into first principle. Therefore, f prime x equals to limit x plus h squared minus x squared over h as h approaches to 0. Okay, so we substitute h equals to 0 into that function. So we get 0 over 0. So we need to do something. Just expand that function. So limit x squared plus 2xh plus h squared minus x squared over h, and we can cancel out x squared. Next, we can factorize h. So it's become limit h times 2x plus h over h. So from that we can cancel out the h. So we substitute the value of h equals to 0 into that function. So we get 2x. Next, fx equals to 1 over x. So we substitute into the first principle. Therefore, f prime x equals to limit 1 over x plus h minus 1 over x over h as h approaches to 0. So if we substitute h equals to 0 into that function, we get 0 over 0. So we need to change the form of the function. Equate the denominator and try to simplify it. So we get limit negative h over x plus h, x and h as h approaches to 0. So from that we can cancel out the h and we can substitute h equals to 0 into that functions. So we get negative 1 over x squared. Now we continue with derivative of a function at any point. The derivative of a function fx at a point x equals to a, written as f prime x, is defined as f prime a equals to limit f a plus h minus fa over h as h approaches to 0. If we write h equals to x minus a, then f prime a equals to limit fx minus fa over x minus a as x approaches to a. Example 2. Find the derivative of fx at the given point. Okay, fx equals to 3x squared plus 12, where a equals to 2. So from the first principle, at any point a, f prime a equals to limit fx minus fa over x minus a as x approaches to a. Therefore, f prime 2 equals to limit fx is 3x squared plus 12 minus fa, meaning that we substitute x with 2. So we get 24 over x minus 2 as x approaches to 2. And then we simplify the function. So we get limit 3x squared minus 12 over x minus 2 as x approaches to 2. Then if we substitute x equals to 2, so we get 0 over 0. So we need to do something. So we factorize that function. So we get 3 times x squared minus 4. Factorize again for x squared minus 4. So we get 3x plus 2x minus 2 over x minus 2. So from that, we can cancel out factor x minus 2. And then if we substitute the value of x equals to 2 into that function, so the answer is 12. Fx equals to x minus 2 where a equals to 1. Therefore, f prime 1 equals to limit fx. We need to substitute with function which is x minus 2 minus fa, meaning that we substitute x here with value of a equals to 1, so we get negative 1. So the functions become limit x minus 2 minus x minus 1 over x minus 1 as x approaches to 1. So from that we simplify, so we get limit x minus 1 over x minus 1 as x approaches to 1. So here we can simplify it, it becomes 1. So limit 1 is 1. Example 3. Determine whether the function fx equals to x squared where x less or equals than 1 and x plus 1 where x greater than 1 is differentiable at x equals to 1. From the piecewise function given, we can draw a real number line. So here is 1. So for x less or equals than 1, the function is x squared. For x greater than 1, so the function is x plus 1. So from that, we know that if x approaches to 1 from the left, so the function is x squared. If x approaches to 1 from the right, so we need to use the function x plus 1. So to determine whether the function is differentiable or not at x equals to 1, so we need to check from the left and from the right. So we substitute into the first principle. First, we start limit as x approaches to 1 from the left. So if from the left, the function is x squared. So x squared minus 1 over x minus 1. So from that, we need to factorize numerator. And from that, we can cancel out the factor x minus 1. And then we substitute x equals to 1. So we get limit x plus 1 as x approaches to 1 from the left. So the answer is 2. If limit x approaches to 1 from the right, so the functions becomes x plus 1, okay, and then minus 2 over x minus 1. So we simplify the function. So we get limit x minus 1 over x minus 1. So it becomes 1 here. So limit 1 equals to 1. So therefore, limit fx, x approaches to 1 from the left does not equals to limit fx, x approaches to 1 from the right. So therefore, fx is not differentiable at x equals to 1. End of the subtopic 2.1.